Adjunct Professor Moran, Microeconomics 112. We're discussing the concept of elasticity, how responsive quantity demand is to a change in price. Elastic, very responsive, inelastic, not very responsive. We've talked about the steepness of the curve. We've talked about the descriptive method, many substitutes, luxury necessity, percentage of income, and durable versus non-durable. We're now going to talk about the arc midpoint formula. This can be a little involved. So before we actually calculate the arc midpoint formula, or show it to you, we're going to show you what it's not and how it gets to be so complicated a formula. First, you might think that elasticity is a slope measure, but it's not. Slope, the steepness of the line, is measured by the change in y over the change in x. That's just arithmetically the value, the formula for slope. But this would mean that our y value, price, is caused by a change in our x value, quantity. A change in price resulting from a change in quantity demanded. Now sometimes that's true, but for this application we want to know the opposite. We want to know what happens when the businessman changes his price, causing a change in quantity. So we want to know what change in quantity will result from a change in price. I hope you can see that this formula is summarizing that concept. The change in quantity caused by a change in price. That would mean that it's the change in x divided by the change in y, which is the inverse of the slope. So first of all, the formula for elasticity is the inverse of the slope. Now, the problem is that a dollar change in the price of gum is way more important than a dollar change in the price of a car. So we don't want to measure the change in price in raw units, 2 minus 1. We want to convert that to a percentage. So the dollar percentage change in gum is significant, and a dollar percentage change on a car is insignificant. So we need to convert this to a percentage change. That's what this formula is. The change divided by where you started from gives you a percentage change. In terms of percentage change in quantity, divided by the percentage change in price. Significant for gum, insignificant for car. The problem though is, if you do it this way, then believe it or not, you're going to get different answers. Say if you go from $1 to $2 and $2 to $1. That's because the denominator is changing. A change from $1 to $2 is a 100% change. It's a 100% increase to go from $1 to $2. But believe it or not, if you go from $2 to $1, that's still a dollar change. But you're starting at 2, and that decrease of $1 is now only 50%. What that means is you'll get one number if you're going from $1 to $2, and you'll get a different number if you're going from $2 to $1 over the same stretch of the demand curve. In order to avoid that, we're going to use something called the arc midpoint formula, and we'll take the change in price halfway and the change in quantity demanded halfway, the arc midpoint formula. And so that formula is going to look like this. It's going to look like this. A change in quantity 2 minus quantity 1 divided by quantity 2 plus quantity 1 divided by 2. This creates the midpoint. And then for the denominator, it's all over the change in price in raw terms divided by it as a percentage change, P2 minus P1 divided by 2. This dividing by 2 gives us the midpoint from here to here, and this expression dividing into this one gives us a percentage change. And it all results from this. Now, in addition, one last thing, demand is always negative. Demand is a negative relationship between price and quantity. So why bother constantly repeating the negative sign? Let's just make it the absolute value. So if you remember our first sheet, using the descriptive method, they were all positives. We didn't bother saying that they were all negatives. because there's no point to it. So we're just going to take the absolute value. So the formula we're going to use is the arc midpoint formula of demand elasticity, the inverse of the slope, taken as a percentage, as an absolute value.